Hey there, everybody, and welcome to today's lesson on probability. Today is the last lesson on probability. Tomorrow we will have the test review, and then the next day the test. So this is the last day of new instruction before our unit test. So first, let's do our I can statement. Today the I can statement says, I can understand and use the fundamental counting principle. Fundamental counting principle. So first we're starting with a warm-up. It says, make a tree diagram to represent all the possible outcomes if a team plays 3 games in a tournament. We're going to assume that for each of these 3 games, there's only two possible outcomes, win or lose. We're going to assume that there's no tying here. So we would have game 1, game 2, and game 3. So in game 1, they might win or they might lose. Let's do a W or an L. And then in game 2, same thing, win or a lose. So we've got a win or a lose for that one, and then we need to draw a win and a lose for that one also. And then when you go to game 3, same idea. There's a win and a lose for each one of those. Win, lose, win, lose. Win, lose. I'm running out of room. Win, lose. And then we could write all the possible outcomes. Let's just do that super fast. So win, win, win for that first one. Then we're going to go win, win, lose. Win, win, lose. Next up, win, lose, win. And then win, lose, lose. Okay, now to the second half, starting with an L. L, lose, win, win. L, W, W. Lose, win, lose. Lose, win, lose. Lose, lose, win. And then for the final one, lose, lose, lose. So those are the possible outcomes. It looks like there's 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes in this sample space. Let's look at question B. How many outcomes are there for the first game? So for the first game, they can win or lose, right? That's 2 outcomes. For the second game, again, you're not worrying about the first game or the third game. You're only talking about the second game. And it's a lot like the first game. You can only win or lose the second game. So that's still only 2 possible outcomes. Same thing for that third game. They're either going to win it or they're going to lose it. That makes 2, so we're going to put a 2 in this spot as well. So how many outcomes are there in the sample space? Well, we just said there were 8 because we counted them up. But if you're remembering that shortcut method from yesterday's assignment, if you found that, then let's use that again here. Let's read it. It says, can you see a shortcut for finding the number of outcomes in the sample space without going to all this trouble of making a tree diagram? Yes, we do, and it is multiplication. How do we multiply? Well, basically, you're going to take these 3 numbers. The number of outcomes for the first game or the first event, whatever it is, the number of outcomes for that second event, and the number of outcomes for that third event, and you're going to multiply them together. 2 times 2 times 2. Let's see, 2 times 2 is 4. 4 times 2 equals 8. So that is our nice magical shortcut. With 3 games, making a tree diagram is not so bad. But if they had like 18 games, I did the math on it, it was over 200,000. So you could definitely get in the weeds pretty fast if we were trying to make a diagram for anything complex like that. Okay, let's keep going. It says here, everyone knows how to count, so it seems like learning counting principles, like what we're learning today, is called the fundamental counting principle. Counting principles is kind of silly, but don't worry, it's more than just counting. You guys know how to count. Counting the number of outcomes in the sample space is pretty easy, yes, as long as there aren't very many. Then it would get very hard. However, the more outcomes there are, and the more events that are included in a compound event, the more complicated the counting can be, right? Like we were talking, if there were 18 games, it would be crazy complicated. Or what if there are more outcomes, not just winning and losing? What if we were spinning a spinner and there were like 9 colors on the spinner and we had to spin the spinner 6 times? Can you even imagine? That'd be a huge tree diagram too. Here is where the fundamental counting principle comes in. So the fundamental counting principle is just exactly the same as what we were talking about up here, where you can multiply. So let's just read this official definition of it. If a task consists of a sequence of choices in which there are, we're going to call it P. P can represent any number. P selections for the first choice. So here there were 2, right? So in this case there would have been 2. But like I said, P is going to change based on the problem. So say there are P selections for the first choice, and then who knows how many for the second choice. We're going to call it Q. Q might represent anything. And then R selections for the third choice. Again, who knows what R is going to be? It's going to be different in each problem. And so on. Then there are P times Q times R, different selections that can be made in total. So all this is saying, is putting it in nice formal math speak, they're just saying you can take the number of possible outcomes from the first event, the second event, third event, and however many events there are, multiply them all together, and that gives you the whole sample space. Let's keep going. So, in summary here, we can use multiplication. Multiplication as a quick way to count the number of outcomes in the sample space of a compound event. And remember, a compound event is where more than one thing is happening. Here they played 3 games. If it was just one game, let me try that again. If it was just one game, that would be a simple event. But when you have 2 or 3 games, that becomes a compound event. Okay, so looking at example 1, this might look familiar. You may have seen it on your homework assignment yesterday. It says how many different kinds of plans are available if the Mega Cellular phone company offers the following choices. Okay, so let's look at these. In the first event, in other words, the first choice, right? You can have limited data or unlimited data. So how many choices are those? 2 different options, right? Okie doke. What about in the second event, or the second choice they're giving you? 1,000, 2,000, or 3,000 minutes. 1,000, 2,000, or 3,000 minutes, that's 3 choices right there, right? So 3 choices for number of minutes. And then the final choice you're making is Droid or iPhone. 2 different ones to choose from there, so we're going to put a 2. Now you could make a tree diagram, but it's a lot of work. I'm going to skip it. Instead, we're just going to multiply all these together. You're going to do 2 times 3 times 2. Let's see, 2 times 3 is 6, and 6 times 2 is 12. So the total number of different kinds of plans would be 12. All right, example number 2. A man has 6 ties, 5 shirts, 3 pants, and 2 pairs of shoes. How many different outfits are possible? And then it says, imagine that tree diagram. I mean, really, it would get kind of messy. It would be huge. It would take up your whole paper, and it'd be a huge pain. So let's just skip that. So how many choices for this first event, which is picking a tie? 6 choices. How many choices for this second event? 5 shirts. He has 5 choices. And how many choices for that third event? He has 3 pants to choose from, so we've got 3 choices. And for that final event with shoes, he only has 2 pairs of shoes to choose from, so we're going to do a 2 there. You just multiply all those together and we'll have our answer. 6 times 5 is 30, 30 times 3 is 90, and 90 times 2 is 180 different outfits possible. Now, I don't know if all of those are actually going to match and make a good outfit, you know what I'm saying? But we'll just go with it. Maybe they're all gray, who knows? Okay, use the fundamental counting principle to find the total number of outcomes in each sample space. For this worksheet, Y is not a vowel. Okay, I guess we'll need to know that in just a second. And I want you to be careful here. It says rolling 2 6-sided die. So should we just multiply 2 times 6? No, we should not. We should think about it really carefully. Think about it. We're having 2 events because we're rolling 2 dice, right? Okay, so we have 2 events. We need to figure out how many different possibilities are in the first one and how many possibilities are in the second one. So the first event is rolling 1 die. How many different possibilities there? 6. So I'm going to do a 6 here for the first event. Now the second event is rolling another die. And how many possibilities are there? Another 6. Yes. So 6 times 6 is 36. Okay, so you have that. Now, we're going to circle back to this in a second because there's a question on your assignment about it. But for now, let's keep going to the next number, which looks like it's number 3. Why is it number 3? I think that these are actually coming from the assignment. I did not notice that a second ago. Okay, well, cool. These, just so you know, these are all from the assignment. Who knew? So number 3 from your assignment says picking 1 consonant and 1 vowel. Well, I didn't know this off the top of my head, but I figured it out, and there's 21, whoa, let me try that again. 21 consonants and 5 vowels, A, E, I, O, U. And so total of 26 letters, right? So what are the different possible outcomes when you pick 1 consonant and then 1 vowel? Well, to figure that out, you're going to do 21 times 5, and I'm thinking that's 105, but let's just be sure. 21 times 5 equals, yeah, okay, good. So 105 possible outcomes on that one. Let's go to number 6 here from your assignment. Number 6 says rolling 2 dice and tossing 2 coins. So again, don't just grab those 2s and multiply them together. That's not going to get you the right answer. Read it and think about it. So you're rolling 2 dice. So in the first event, event number 1, you're rolling a dice. And that has 6 possible outcomes. So I'm going to do a 6. But you're not just rolling 1 dice, you're rolling 2, right? So there's a second die that you're also rolling, which will also have 6 possible outcomes. Okay, so this is the first die, and here's the second die. Now it's time to toss a couple of coins. So for the first coin, how many possible outcomes? Heads, tails, just 2, right? So I'm going to do a 2. And then for the second coin, how many possible outcomes there? Heads or tails. That's it, so I'm going to do another 2. And then you just multiply. 6 times 6 is 36, times 2 is 72, times 2 is 144. You know what? We're going to grab our calculator and just make sure about that one too. Yeah, 144 is good. So 144 combinations for that one. What do you think on number 11, tossing 4 coins? So you have 4 different coins. How many different possible outcomes for that first coin? 2. How many different possible outcomes for the second coin? 2. How many outcomes for the third coin? 2. Still heads and tails, right? And for the fourth coin, it's still just heads or tails, so it's still 2. So for tossing 4 coins, 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 possible outcomes. Okay, and now number 13. The number of possible outcomes if 2 quarters, 4 dimes, and 1 nickel are tossed. It says be careful, they're all just coins. That's just a trick. Not a trick, it's a tip, because we don't want you to just grab these numbers and multiply them together. That will get you the wrong answer. So on number 13 from your assignment, let's be really careful. It looks like we need 2 quarters. So the first quarter is either heads or tails. That's 2. The second quarter is the same, heads or tails. Okay, I'm just going to kind of bracket it and label it quarters. That's not necessary. It just helps me remember where I am in this problem. Now we have 4 dimes, and the dimes are, oh gee whiz, they're also heads or tails, aren't they? So 1, 2, 3, 4 dimes, all multiplying together. Here's my dimes. And now finally we just have 1 nickel. So that is also heads or tails, and I'll just do it like that. So let's see, I have 2 quarters, 4 dimes, and 1 nickel. And now I just need to multiply them all together. So 1, 2, 3, 4, 5, 6, 7. Let's multiply 7 2s. 3, 4. Here, I'll show you my screen. I'm on this bottom line here. I've already done 4, 5, 6, 7. Looks like we get 128. Let me make sure I did that right. 1, 2, 3, 4, 5, 6, 7. You get 128. If you're liking to do something differently, you could do it that way, but only if you get what's going on there. You're totally fine to do it this way. 128. Okay, so 128 outcomes with that. Let's keep going. Example 3. What about choosing a 3-digit PIN? Do you know what a PIN is? Personal identification number. If you have a bank account and you go to an ATM, usually you have to enter your PIN. Usually it'd be 4 digits, but in this case it says 3 digits, so let's go with 3 digits. So you have 3 different digits. Now the digits have to be numbers, okay? So how many numbers can you choose from that are a single digit? You're going 0 through 9, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's easy to think there's only 9 to choose from, but that would be leaving out 0. 0 makes it 10. So for each one of these digits, assuming you can repeat a number, which usually you can, you're going to have 10 choices. So 10 times 10 is 100, times 10 is 1,000. So 1,000 different number combinations possible when you're choosing a 3-digit PIN. Now what about a license plate? So in this case we're going to do 3 digits. So it's going to be number, 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 followed by 3 letters. Letter, letter, letter. So for the numbers, just like over here, there's 10 different digits to choose from, 0 through 9, right? So 10 times 10 times 10. Now how many different letters are there to choose from? There are 26 letters in our alphabet, so we're going to have 26 on each of these blanks. I should have made my blanks bigger. And now let's just do the math on that. So 10 times 10 times 10 times 26 times 26 times 26. Oh, this is going to be big, isn't it? Oh, yeah, nice. Okay, so it's going to be 17,576,000. Let's write that down. 17,576,000 different combinations for those license plates. That's a lot. That will definitely take care of the whole state of Utah for a little while now. I know we're growing, but it'll take a little while before we get there. What is the social security number is that thought question. Do you know your social security number? If you do, make sure you keep it secret. That's not the kind of thing that we should be telling everybody for sure. But if you know it, think in your head, how many digits does it have? You're going to have 3. And then usually there's like a little dash, right? And then 2 more. And then another dash. And then 1, 2, 3, 4 more. Okay, so for each of these digits, there's 10 possible numbers. So this is a lot of 10s to multiply together, but I'll let you guys do the math on this one. If you multiplied all those 10s together, what number would you get? And then that tells you how many different possible social security numbers there are. Now that didn't really say in the question to find the total number, but I mean, that's what we're doing. So let's just go ahead for fun. Now I'm going to circle back to this question number 1, rolling 2 6-sided dice. If you have your assignment printed out already, great. Go ahead and turn to the second page. If you don't, that's totally fine. So number 26 on the second page, this is the last problem. Basically, you're just filling out the entire sample space for rolling 2 6-sided dice. So you might roll a 1 and then a 1, or you might roll a 1 and then a 2. You might roll a 1 then a 3, 1 then a 4, 1 then a 5, 1 then a 6. Okay, that's all the 1s for the first roll. And now let's do 2s for the first roll. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Now what if we do a 3 for the first roll? 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and then 3, 6. And then you would do it with 4 and continue across, then you do it with 5, continue across, and so on. Now if you're an avid board game player like me, sometimes you play games where it's really helpful to know how likely it is that you're going to roll certain rolls. You've probably already figured out this. Not so often that you roll a 1 and a 1, or that you roll a 6 and a 6. Some of these numbers in the middle, like 7s, 6s, those kind of numbers are a lot more frequent. So if you're interested, you could figure out the probability of rolling different numbers and kind of keep that in your mind for next time you have board game night. Just a thought, this is the end of our video. Thank you so much for watching. Let me know if you have any questions. I love hearing from you, and I will see you next time. Bye.